Hello and welcome to another session of the Digital WE Days. My name is Son and I will moderate this webinar today. Our topic of today is PowerBusbar PCB efficient high current solutions for modern PCB design. Our speaker today is Günter Behlau from Würth Electronic ICS. He is application engineer for components. So Günter, hello.
Hello.
Welcome.
Welcome.
Cool to have you here. He will hold the presentation and then he will answer your questions. Distributing high currents on a standard PCB sounds ambitious, but PowerBusbar makes it possible. What sets this technology apart? Let's dive in. Stage is yours.
Yeah, thank you. And I also wish you a welcome. Today we will covering the following points about PowerBusbar. At first, the principles behind PowerBusbar PCB. What are the requirements for implementation such a system in your application? How is the busbar mounted on the PCB? What are the benefits of this technology? The difference from other busbar mounting options. Then I will show you some practical examples, and after this we will have a Q&R session. But let us start with the Würth Electronic Group. We have three divisions. One is the Würth Electronic ISOS Group. They deal with passive components, thermal components, radio module and so on, and also with electromechanical components like rack tube. On the other side we have the Würth Electronic CBT. They are producing rigid PCB, flexible PCB and also stencils. And on the other side we have the Würth Electronic Group ICS, the Würth Electronic ICS. And we are producing system solutions, power distributions, half-house solution, electronic controllers, HDMI solutions for agriculture machines, building or for the building industry, and also for buses and trucks, to name something. On this side we have the PCB components where I come from, and we offer the power elements that we use in our systems also to our customers. Let us look at the Würth Electronic ICS, the components team. We have three product groups. One are our power elements. These are high current connectors to distribute high currents into the PCB. You have the option of press fit, SMD, THT or THR, and we have also screwable and pluggable solutions. Then we have the product group PowerBusbar. This is the main topic for today, for increasing the current carrying capacity of the PCB, and also our power sockets. These are press fit connectors to mount fuses or relays on the PCB. But let us have a look on the principles behind the PowerBusbar PCB technology. The PowerBusbar technology connects the busbar and the PCB by using the proven massive press fit technology. You can see it here. The technology relies on the massive press fit technology, which has proven itself when a high performance gas tight electrical connection characterized by a very low electrical resistance is needed. And it focused on applying this proven connection technology directly to a copper busbar and processing it simultaneously with a high current contact called power element in a single manufacturing step. You can see it here. And it utilizes the contact pin of the power element to create a reliable connection between the power element, the PCB and the bus bar by pressing them into precisely manufactured plated through holes. This is the principle behind the press fit technology with these connection points. And so this technology enables the use of standard PCBs, eliminating the need of expensive PCB designs with multiple copper layers or embedded copper inlays. But let us have a look on the press fit technology itself. The press fit technology creates a seamless and very homogeneous material transmission between the press fit pin and the PCB copper. This connection is a gas-tight connection through a cold welding process. And thanks to the cold welding process, we have a significantly less contact resistance between the press fit pin and the copper sleeve in the PCB. Since this is a cold welding process, you have no thermal stress on the PCB and so have no risk of cold solder joints. This connection method has an excellent mechanical stability and high mechanical strength, and it is proven in many vibration tests that we have done with our systems. Also, it is possible with the massive press fit technology to create a compact design, because you can use press fit components on both sides of the PCB, and so you can reduce your installation space. But what are the requirements for implementation such a system in your application? At first, you need a bus bar. The bus bars we recommend has a typical thickness of 1.0 up to 1.5 millimeter. The shape of the bus bar will always be customized to meet your requirements on your application. But when you think about the width of the bus bar, please keep the power element in mind that you will use for your application. At next, you need a power element, and you need a power element with press fit technology. The power element should be selected based on the required current carrying capacity that you need in your application and the interface type, such as screwing or plugging. Also, you need a printed circuit board, and we recommend that you use a standard thickness up to 2.0 millimeters. And very important is that the PCB hole specification must be comply with our Word Electronic ICS requirements based on the selected power element. And you can see when you use a 2 millimeter thick PCB with a 1 or up to 1.5 millimeter thick bus bar, then the typical pin length of our power elements with 3.5 millimeter fits to this application. Otherwise, we can also adapt or customize a special power element for you. But the next thing is what you need is a press fit pad. It is also very important because the press fit pad supports the PCB during the press-in process and prevents bending and gives mechanical stability during the process. Also you need a suitable press-in tool, and this must be tailored on the power element that you will use. The last thing is that you need a press, and we say for prototype production you can use a simple toggle press, but for serious production we recommend that you use a press with force stroke monitoring, so you have a better control over the quality of your process. And we came to the conclusion, when the specified guidelines or the guidelines what I've told to you are followed, the press fit technology becomes a really simple and reliable step in serious production. Let us now have a look how is a bus bar mounted on the PCB. The PowerBusbar processing steps are, at first you have to decide is a bus bar positioned either below or above the PCB. When it is positioned below the PCB, the press fit pad, it's not so easy here, press fit pad includes a recess, you can see the recess that precisely matches the contour of the PowerBusbar PCB. If the bus bar is larger, we can also add centering holes and in the bus bar, and you can set centering pins in the press fit pad. Then the PCB is placed over the bus bar on the press fit pad, and the power element is aligned with the interface of the PCB, and the suitable press-in tool is applied on the power element. And by using a press, the power element is pressed through the PCB into the bus bar. What is very important, that the connection is reliable and the quality is good. We say that both the bus bar and the PCB must be optimally supported during the press fit process to prevent any damage on the bus bar or on the PCB. That is very important. The next thing is that the interface between the power element and the PCB complies with the drill hole specification that you can get from us. It's also very important. We met this always that is sometimes a problem. And also that the interface between the power element and the bus bar is optimized to support the positioning of the bus bar either above or below the PCB. So you cannot change. If you have one project where you use the bus bar below the PCB, you cannot change and use it on the top side of the PCB. We have to adapt the interface to this position. And when you also follow this, then we say the press fit process established an electrical and a mechanical stable connection between all components, ensuring high reliability. What are the benefits of this technology? The PowerBusbar technology offers at first cost advantages because cost-effective standard PCBs can be used. There is no need for many copper layers and there is no need for copper inlays. So the PCB structure is simpler and can more cost-efficient produced. Since the bus bar is mounted on the PCB together with the power element in a single step, you have an easy installation process and there is no need to fix the bus bar in an additional processing step. The connection method, the massive press fit technology itself is safe and reliable, and it is one of the most robust and reliable connection technologies. We have proven it in many applications also, and it offers one of the lowest failure rates in the market. PowerBusbars have a high electrical conductivity because they are made from copper, pure copper. So you have a low loss power transmission, and they provide localized current enhancement and applying increased current only where it is needed. Not over the whole PCB, only where it is needed, from one point to the next point. You have also a high thermal conductivity, so busbar dissipate heat throughout the system effectively and it prevents hotspot, and you have also a higher reliability of your all-over system. Since the bus bar are always be customized, and so they will fit your application, we say you have an easy integration and adaptability into existing systems. And all our bus bars comply with the standard reach and rows regulations. But what are the different from other mounting options? We see mounting advantages when you use such a system. At first, the bus bar are mounted directly onto the PCB through the power element in a single step. So there is no need for extra fastening or extra processing step. There is also no need to go from one connection point to one connection point with a cable lugs or with copper bridges. No? And so you will also reduce the numbers of screwing connections that you have in your application, and this will also increase the reliability of the all-over systems. And since the bus bars are lying flat on the PCB surface, this results in a compact design and also in a flat system design. Let us have a look on some practical examples. This PCB shows a PCB that is used in a bus application, and here we use the bus bars for the in and output of a relay and a battery disconnect switch. And what you also can see here in this application, we use the press fit components from both sides. So you have the bus bar on when you look on one side, you have it on the top of the PCB and also on the bottom of the PCB. So you have also a compact design. And the bus bars, these are the only high current paths in these applications. So the rest of the PCB could be standard. This application shows also the in and output of two contractors that is also used in a vehicle. This is a bus application, and here you can see the contractors are directly screwed on the power element that is directly pressed into the bus bar, and so we have only here two small high current paths in this complete PCB. And that is good when you use a bus bar in such a system build-up. The next application is nearly the same, is a battery disconnect unit. And here the bus bars are little bit larger, and this has also the advantages that this bus bars dissipate heat out of the system. And the last example, what I want to show you is a very compact PCB design. And here we have components on this PCB that generate heat. And you can see we have used here a large copper bus bar. At first it is mounted on the top of the bus bar. That was the reason why I want to show you also this application. And we have a big copper surface, and the goal was also here to have a good heat management of this small and high integrated application. And this was also possible with this technology. Now I want to show you some product prospects, what we will launch in the near future. And we think this new product will also have some advantages for you. It will be a new PowerBusbar variant. We will call it PowerBusbar Press Fit. And these are modular bus bars with different sizes made of a special copper alloy, and is also used for increasing the current carrying capacity of the PCB, but it is for effective tracking and support existing PCB trays. So you can see you track the PCB trays directly. No? So, but with the different sizes, with the modular sizes, with this modular design, you are flexible in the design of your conductor paths, and you will increase the current carrying capacity, but also the heat management, because these bus bars act like a heat sink, or you can also act like cooling ribs. No? So you have also the adaptability to complex layouts, and we say this new product will have cost advantages, because we can these bus bars are standardized and we can produce this in higher quantities. So we see here cost advantages for you. And the assembly method is also the proven massive press fit technology, which is very reliable in many and used for many applications. This brings me to the end of my presentation. You can find more information on our webpage powerelement.com. There can you find technology information, more product details, a wide range of our product, but not all. We have many products in our portfolio, but you can also find data sheets. You can ask for a sample or get in touch with us. And so I would like to say thank you for your attention.
Yeah, thank you, Günter, for your presentation. Now we'll come to your questions. Before we start with the live Q&A, I will share the handout from the presentation, and now everyone can download it. Okay, then I would say, are you ready for the questions?
I take my glasses.
Yeah, perfect. Okay, then I think we can start. I would start with this question. Is it okay? Yeah.
Sorry, I think this answer we have to answer later. I have to ask my colleagues how it works in Altium. No?
Yeah, no problem. Okay, then next question. Is there a thermal resistance value we can use if the bus bar also acts as a heat sink?
Yeah, the copper itself has a thermal conductivity, and this is the only value that we can share to you.
Thank you. Okay, next question. Is it possible to order bus bars in low quantities for projects with low volume?
Yes, it is possible. We do it, but yeah, I think this will be a little bit more or that drives cost. And so we say the new product variant, when we produce it in higher quantities, I think that will be also a good solution for smaller quantities. But yes, we also offer small quantities for smaller projects. It's no problem.
Okay, thank you. Then next question. What about EMC, electromagnetic compatibility of this technology? I think from the bus bar, but yeah. Do you know what?
Yeah, yes,
I mean, yeah.
I know.
Okay.
I'm thinking about.
Yeah. Sorry.
Because we have a massive press fit element, and normally we act with DC, and I think we have not really something to do with EMC connection in our application, because we have no high frequency. We are distributing high currents and no signal currents over the systems.
Okay, thank you. Then next question. How is the connection from the busbar to a power semiconductor intended?
Power semiconductor. Can you help me? I think I have to check it and give this information later.
No problem. What is the drill specification for the copper busbar?
The drill specification we do not share in general. We have to know where is the busbar positioned, either above or below the PCB, and we make the drills for the busbar accordingly to our internal specification. On the drawing you see only the nominal values, but you can see the nominal values, but not more.
Okay, thank you. Then next question. This one.
The busbars are normally bar copper busbars. We use bar copper busbars, but also tint copper busbar, and we have no insulating on the busbar itself. So it is not planned that we have an insulation of the busbar. Maybe you can use heat sink to have an insulation that you can use, but normally not, because it works, I think, not really properly together with the press fit technology, because you have a bigger insulation, and so you have not a really a good contact between the PCB and the busbar itself. It could be a problem when you have an insulation between that.
Okay, then next question. How good is this with automotive grade vibration testing?
Yes, I think that is not a problem, because we use this technology in our products, in our systems, and we are working for the automotive industry, for the building industry, for the agriculture industry, and we have high vibration demands on our applications, and the busbars are built in these applications. So this connection method is really stable in terms of vibration.
Thank you. Then next question. Are there any press fit elements to connect the busbar to the PCB without any connection terminal?
Yeah, I think I think what you mean. Yes, we can also offer press fit components without any interface, without, they have a flat surface, and so you can press or fix the busbar on the PCB with such a terminal. It's only for fixation, such a busbar, not that you use it for connection, a cable or a busbar itself.
Okay. Then Next question. Do you provide libraries etc. for the most common ECAD softwares? incl.
Yeah, for our Power Elements in our webshop under powerelements.com you will find also Altium files for our Power Elements.
Thank you. Then next question. Do you provide the footprint for the Power Element ideally library?
Yeah, we talked the questions before. We give the footprint, or you can load the footprint down from our web page for the Power Element that you will use. It's an Altium file, and the footprint is there. Otherwise, you get from us a drill hole specification. This is also important for the footprint. With the drill diameter and the final diameter, the thickness of the cladding. So you get all information to have or to create a footprint, or you can download a footprint from our web page.
Okay, then what about the current return paths? It is recommended to route trace above each other for low inductance. But how can this be achieved with such busbars?
Yeah, I think this is the questions for system build up, and I will ask our colleagues and we will answer this question later.
Okay, thank you. Then I see no more questions left in the chat. So yeah, if you have any questions, write in the chat, and then Günter will answer them later via email. So thank you very much for your presentation, for your answers, and for your time. Thank you for your attention. Thank you for interesting. Now I will share the link to our Digital WE Days homepage. So check it out. Register now. So we had a lot of other sessions planned during this week. Yeah, thank you very much for joining. Have a good day and bye bye.